All right, we're still learning trigonometry in Unit 2. We're on the third day. I like this lesson. I'm going to try to keep it under 15 minutes. Okay, so we're going to learn about coterminal angles. Coterminal angles are angles where you can keep adding 360 and adding another 360. So if you have 30 degrees and you add 360 to it, that's a coterminal angle. Add another 360, that's a coterminal angle with 30 degrees. So their terminal sides coincide. So you can find coterminal angles by adding or subtracting 360 degrees if you're working with degrees, or if you're working with radians, you would add or subtract 2 pi. So we are going to practice the first two. So if you've got an angle in degrees, if I want a coterminal angle, and there are an infinite number of coterminal angles, but we're just going to show you examples. If I take 60 degrees and I add 360, I get 420 degrees. Now remember, no calculator, so try to do this without a calculator. You'll thank me next year. There we go. Two examples of coterminal angles. Now, when you have an angle in radians, you have to add 2 pi. When you add 2 pi, you have to add it in with the same denominator. So 2 pi is equal to how many sixths? That's 12 sixths. That's equal to 2 pi. So I can add my 5 pi plus 12 pi, and I get 17 pi over 6. Same for if I want to subtract 2 pi. Well, I have to subtract 2 pi in terms of sixths, so I'm going to subtract 12 pi over 6, and 5 minus 12 is negative 7. So there are two examples of coterminal angles. So here are the next two examples. Hope you tried them before I showed you the answers. Make sure you can add and subtract 360. The second angle here, we are adding 6 pi over 3 because that's equal to 2 pi in thirds. 6 pi over 3 is equal to 2 pi. All right, moving on. This is review from last class. So what I'd like you to do is press pause, see if you can do these problems, and we will come back, okay? So now we're back. The first thing you need to do is make sure you draw your X and your Y axis. You draw the angle, 495 degrees. You got to subtract 360 first, then you find 135. Where is 135? Draw an estimate of where it's at. It's 90 plus 45. So we know that's a middle angle, and we know we're asked to find the sine, which is Y. When you are in the second quadrant, Y is going up, so it's positive. So that's root 2 over 2, positive. For B, negative 600 degrees. If you add 360 twice, you get 120. Draw it on your XY axis. Where's 120? Okay, so that's 90 plus 30. So in this right triangle, for special right triangles, 30, 60, 90, we're asked to find the cosine, which is the X value. X is negative going to the left. So it's negative, and it's the short value, so it's negative 1/2. For C, 17 pi over 4, we're going to subtract 8 pi over 4 twice because we have to subtract 2 pi. 2 pi equals 8 pi over 4. When we do that, we end up with pi over 4. So what's the tangent of pi over 4? Pi over 4 is the middle angle. I love it when it's in quadrant 1. So that's just a root 2 over 2 over root 2 over 2. And that's 1. And those are just values in the quadrant. In quadrant 1, you've just got to memorize those values. You need to know that the sine of pi over 4 and the cosine of pi over 4 are each root 2 over 2. And when you find a tangent, you take those two values and you put them, sine over cosine is the tangent. For D, when you add 12 pi over 6 to negative 13 pi over 6, you get negative pi over 6. So first of all, you go ahead and draw it. So we've got negative pi over 6. In the fourth quadrant, the y value is negative. That sign is the y value. So that's going to be negative, and it's the short one, negative 1/2. For negative 270, that's starting here and going around 1, 2, 3, negative 270. So that's the same thing as tangent of 90. The tangent of 90 is sine over cosine. Sine is y, cosine is x. 1 over 0, that's undefined. And f, when you add 6 pi over 3, because that's equal to 2 pi in thirds, you get negative pi over 3. Go ahead and draw it on your xy axis. That's a tall angle. You're asked to find the x value. The x coordinate of that point is going to be positive, and that's the short distance, so it's 1/2. Moving on. Some students like this, some students don't. Okay, I don't particularly use this a lot, but some students like this. When you, to remember the signs of sine, cosine, and tangent in each of the quadrants, you can remember the, what's it called? Mnemonic acronym? I'm not an English teacher. So all students take calculus. All of them, sine, cosine, and tangent, are all positive in quadrant 1. Students, S remembers that sine is only positive in the second quadrant. Tangent is only positive in third quadrant, and cosine is the only one that's positive in the fourth quadrant. So when you give them problems like this, where you're asked to find, or sorry, identify which quadrant the angle is located, they usually give you 2 pieces of information. The first piece of information narrows it down a little bit, and the second piece tells you which one it's in. So, for example, when they tell you the sine of x is less than 0, that means the sine is below, because sine is y, we are currently below the x. Oh, that's too big. Let's try a little smaller. Come on. Okay, better. We're below, that one first piece of information tells us we are below the x-axis because y is negative. Okay, now the second piece of information we are given is that the cosine is positive. The cosine is greater than 0. The cosine's only positive in these 2 quadrants because it's positive. That's where the x values are positive. So to the right of the y-axis. So what do they have in common? We are, oh, geez. We are clearly in quadrant 4. So that's your answer, quadrant 4. Okay, go to B. Where is the tangent positive? The tangent is positive when both the sine and the cosine are both the same sign. Okay, so that gives us, narrows it down to 2 quadrants. Now they tell us also the cosine is less than 0. The cosine is x. Where is x less than 0? X is less than 0 down here. So that is the quadrant that we are in and looking for. Quadrant 3. Moving on to C. They tell us the cosine is positive. Where's the cosine positive? The cosine is positive. Cosine is x. So it's, oh, let's try that again. Where's my highlighter? Okay. This is really not good. There we go. Where the x values are positive. Second piece of information, the cotangent is less than 0. Okay, well the cotangent, tangent, you're going to have the same sign because it's sine over cosine or cosine over sine, tangent, they're just reciprocals of each other. So when I see that, the first thing I'm going to do is I'm going to write where is, come on, the tangent of x less than 0. Okay, where is that? Where's the tangent less than 0? Well, that's going to be in quadrant 4 because in quadrant 1, the tangent is positive because both sine and cosine are positive. In quadrant 4, sine and cosine are different signs because sine is y, and that's going to be down, that's negative, and cosine is x, and that's to the right, right? So that's positive in quadrant 4. All right, and the last one, where's the sine? See if I can get the right highlighter here. Where is the sine greater than 0? Where the y value is greater than 0? And where is the tangent also greater than 0? Boom, right there. So they I need my pen now. They intersect right here. So that is quadrant 1. That's a 1. Okay. Moving on. So in order to do these types of problems, you just need to remember SOHCAHTOA. So given the two trig values, you're asked to find the other 4. The hardest part about these types of problems is drawing the triangle. Where does the triangle go? When you are drawing one of these triangles, depending on the information that you're given, you could be in one of the 4 quadrants. Now you're drawing an angle that's on the unit circle. So you just have to remember, when you draw your angle, your vertex is going to come out of the center here and it's going to connect, because you're drawing a right triangle, to the x-axis. So it's going to look like one of these 4 angles in your bow tie. So for example 4, we're given 2 trig values, find the other 4. So we're given sine, we're given cosine, we have to find tangent, cosecant, secant, and cotangent, okay? All right, so I went ahead and flipped those and wrote them out for cosecant and secant. But once I flipped them, now I have a radical in the denominator, which then I have to rationalize the denominator, simplify as much as I can, and there's your answer. So I did that for both of those. For the tangent, tangent is sine over cosine. If you do the square root of 5 over 5 divided by the cosine, which is 2 root 5 over 5. When you divide two fractions, we never divide fractions, we always multiply by the reciprocal. So what happens is we'll get root 5 over 5 times 5 over 2 root 5. We know that's going to happen. So those 5s are just going to, we can just cancel those 5s. So this is sine over cosine. So it's root 5 over 2 root 5. Well, what's going to happen there? Those root 5s are going to cancel. We have a 2 left. So that's 1 over 2. And the reciprocal is 2. Try it yourself. Moving on. In example 5, we're given the trig ratio in the quadrant, and we're asked to find the other 5. The hypotenuse is always positive. Just remember that. We are in quadrant 3 here because they tell us the cosine is negative. So we know quadrant 3, cosine is negative. It's either got to be quadrant 3 or quadrant 4. The cosine's negative. But then they tell us we're in quadrant 3. So we go ahead and we draw our triangle. We put our values in. The cosine is the adjacent over the hypotenuse. So the adjacent side has to be negative because we're going to the left. And the hypotenuse is always positive. In this case, we use Pythagorean theorem. Pythagorean theorem is never going to give you a negative value. If you are going down or to the left, you've got to throw that negative sign in there. That's a very common mistake to forget. Do not forget that going down or negative is a negative value. So let's go ahead and put those values in. All right, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and this is, you could think of it as sine over cosine, or you could do opposite over adjacent, and these are the reciprocals of those numbers. We don't have any radicals in our denominator, so we can move on. I'd like you to try B, and I'll give you the answer. So press pause, try it, and come back. Okay, the hardest part is drawing the triangle. So hopefully we got the triangle. It's in quadrant 2. The only reason we know it's in quadrant 2 is 1, the sign is positive, so that means the y value is positive. So y is positive up here in quadrant 1 and quadrant 2. And also, what does this say? This tells us that the angle that we're dealing with here is between pi over 2 and pi. Where is that? Pi over 2 is up here. Shoot. Post pause. Right? And pi is over here. So if the angle is between pi over 2 and pi, it's got to be in the second quadrant. All right, now use Pythagorean theorem, get your information. They give you b is 5. We know that's going to the left, so it's got to be a negative 5. Don't forget the negative. Throw those values in, write the reciprocals, and try the last one on your own. Press pause. Okay, let's see if you can see if you got the triangle. I want you to try this on your own first. All right, the triangle is in the second quadrant again because the tangent is negative, so that means sine and cosine are different values. And also, the sine is positive, so the y value has to be positive. The y value has to be above the x-axis. So there we go, second quadrant. Take your information, negative 1 over 3, that's opposite over adjacent. We're going up, so that 1 has to be positive, and we're going left, so the 3 has to be negative. Pythagorean theorem it, you get root 10. And that is the hypotenuse, so it's got to be positive. Throw all your values in, do some rationalizing of the denominators. What I suggest when you get the cosine, this value right here, okay, before you rationalize it, obviously you got to rationalize it for the answer. Flip it first, because then you have to rationalize again if you rationalize it and then you flip it and then you have to rationalize again. So flip it first, because then you don't have to rationalize your secant. And I think, all right, I've got 14 seconds left. So you just have to look at these on your own. Make sure you know these definitions. Write these down if you can. Look at even and odd. You might have to watch a video on even odd. I might have to, maybe I could find a good